So we're back to using dimensional analysis to convert between mass, moles, and particles of substances. And so since the smallest unit of anything is 6.02 times 10 to the 23rd, Avogadro's number, we use that for finding a mole of both molecules and formula units. And so with that, we're going to be using that same dimensional analysis process that we've been using before. So how many moles contain 2.27 times 10 to the 23rd molecules of phosphorus tribromide? We know from the name that that's P, phosphorus tribromide, Br3. So we'll be working with PBr3. And we're given 2.27 times 10 to the 23rd molecules PBr3. And we're going to have to get to 1 mole because we're converting to moles. PBr3. And so in the denominator, to cancel out molecules, we're going to need that 6.02 times 10 to the 23rd molecules PBr3, which equals 0.377 moles of PBr3. How many formula units are in 2.1 moles of lithium oxide? So let's figure out what lithium oxide is. Lithium has a charge of +1 on a periodic table. Oxygen has that -2. And so doing the crisscross, get lithium 2 oxide, Li2O. And here we are starting with 2.1 moles of lithium oxide. And we're trying to get to formula units, so we're going to need to match it up to how many formula units are in a mole. And again, we use that Avogadro's number. Formula units equals 1.3 times 10 to the 24th formula units of lithium oxide. How many moles contain 27.3 grams of lithium phosphate? So lithium has that plus charge. We know phosphate has a -3. So we're going to have Li3PO4. And now we're going to need to figure out how many grams per mole are there because we're converting from grams to moles. So LiPo. Lithium on the periodic table has 6.94 grams per mole. Phosphorus has 30.97. Oxygen has 16.00. I'm going to have to multiply lithium by 3 and oxygen by 4. And all in all, that's going to end up as 115.79 grams per mole of lithium phosphate. And so they give us that 27.3 grams to start with. Again, we're getting to moles. So we need to have that 115.79 grams of Li3PO4 and multiplied out, and divided out, I'd rather, get 0.236 moles of of Li3PO4 that contain 27.3 grams of lithium phosphate. How many grams contain 0.921 moles of iodine pentafluoride? From the name we know that's IF5. So the mass of iodine is 126.90. Fluorine is 19.00. But there's 5 moles here. And so that adds up to be 221.90 grams per mole. We start with that 0.921 moles of iodine pentafluoride. One mole on the bottom, match mole to mole. We're aiming for grams, so 221.90 grams IF5 totals out to 204 grams iodine pentafluoride. How many grams contain 2.14 times 10 to the 24th molecules of sulfur trioxide? That is going to be sulfur, 3 oxygen, SO3, S. Sulfur has a mass of 32.07. Oxygen, that's 16. Go multiply that by 3. And then totaled up is 80.07 grams per mole. So we start a calculation with what's given in the problem, 2.14 times 10 to the 24th molecules of sulfur trioxide. Match molecules to molecules, but we're aiming for moles. And so we use that Avogadro's number again because there's 6.02 times 10 to the 23rd molecules in every mole. But we're not quite there yet. We still have to do mole to grams. So we could just calculate it earlier that in every mole of SO3, there are 80.07 grams of SO3, which calculates out to 285 grams SO3. How many formula units are in 48.6 grams of sodium nitride? Sodium has a charge of +1. Nitrogen, that's a -3. Cross that out, that's Na3N. Sodium has 22.99 grams, 14.01 for nitrogen. Multiply sodium times 3, and that totals out to be 82.98 grams per mole. Again, we start with what's given, 48.6 grams of sodium nitride. And then we use what we just calculated to get to moles, 82.98 grams. for every mole. We still have to get to formula units. And so in every mole, there are 6.02 times 10 to the 23rd formula units. And so when you do the arithmetic there, you get 3.53 times 10 to the 23rd formula units of Na3N, which is your final answer.